Good morning. This is a review for Chapter 10, States of Matter. In the first section, we studied the kinetic molecular theory of matter, and we studied the 5 assumptions that we had, and we said that it's very important to understand them. Of course, ideal gas, elastic collagen, all of these definitions, the ones that are highlighted in yellow, are very important. Here we just continue 3 and 4 and 5. The kinetic energy formula is important to know. And just remember that we said that whenever the temperature increases, the velocity increases of the gas, and therefore the kinetic energy increases. And then we said that the kinetic molecular theory explains physical properties of gases. And we said we've explained expansion, fluidity. As you can see, for each one, there is a certain assumption that explains it. And then we continued with low density, compressibility, diffusion, and effusion. And focus on the definitions of diffusion and effusion. And we also explained the picture or the figure that explains that. So remember when we said that when a gas is able to pass through a small opening, that is called diffusion. So the mixing of that, that's effusion. We said that's effusion. But when these two gases mix together, that is called diffusion. So diffusion is the ability of mixing, of two gases mixing, together, caused by their random motion. The last thing we talked about was real gases don't behave according to the kinetic molecular theory. We said that. And we gave examples on polar and non-polar. Like right over here in your assessment. Remember, we said that non-polar gases are ideal gases and the polar ones are real gases. Then in section 2, we talked about the physical properties of liquids. We defined a fluid. We talked about the densities. The red liquid which is glycerin, has the most density. That's why it settles down in the bottom. And the solid cork has the least density. And we talked about liquids, as we said. Remember, this section is about liquids. We said that they have relatively high densities and relative incompressibility, ability to diffuse, and surface tension. We talked about surface tension, focused on the definition, of course. We've explained this, diffusion of liquids. And then we talked about capillary action. We talked about capillary action. This is to explain surface tension. Remember, minimum surface area. Because of the attraction of the molecules. And over here, evaporation and boiling, we talked about the difference between them. And guys, whenever you see me drawing a star and writing SAT, that means that's either a previous question that came in a test, or just in general, that's very important to know. Of course, because it's one of the College Board requirements to know. We said that evaporation happens on the surface. Vaporization only happens, it's the process, we said, the process in general. And then boiling, of course, is something else. Boiling has to happen at a certain temperature, according to the liquid itself. That's like one of its own properties. And then the last one for liquids is formation of solids. Of course, if heat is released, solids can form. And then in section 3, we talked about solids and their physical properties. And we talked about the behavior of the atoms, or how it is on a molecular level. As you can see, we said they're compacted, they vibrate in their spot, as you can see over here. The arrangement, we took this in first class, how the particles of gases and liquids and solids are arranged. And then we categorized solids into crystalline solids and amorphous solids. We defined a crystal, and we gave examples on amorphous solid, as you can see, glass and plastic. And then we came to talk about the physical properties of solids. Number 1, definite shape and volume. Number 2, definite melting point with definitions. What does melting mean? It's the process, of course. And melting point, supercooled liquids. And then with the third property of solids is that they have high density and incompressibility. They're incompressible because of the arrangement, whether it's a crystalline or an amorphous. And then we talked about crystal particles that are arranged in a three-dimensional lattice, remember? So the crystal arrangement is called lattice. And we defined it. We defined a unit cell that keeps repeating itself. And we showed you the crystal structure as a unit cell. And these are just a bunch of examples on crystalline solids. And over here we just have the fourth physical property of solids, which are low rate of diffusion. Okay, of course, because their particles are packed together, they can't diffuse, they can't move and mix. And then we talked about melting and boiling points of crystalline solids. We said it's highest at metallic bonds, and then covalent network, and then ionic bonds. And then we said covalent molecular polar, and then nonpolar, as you can see. Okay, and of course the boiling points depend on the type of bond between these solids. And then we talked about the binding forces in crystals. So we have ionic crystals, covalent network crystals with examples. We talked about these examples. Okay. And then we said that metallic crystals and covalent molecular crystals. So these are the binding forces in crystals. All of these are solids. So remember, as we categorize them, we said we have crystalline and amorphous. For crystalline, there are different forces in these crystals. And these are the 4, 1, 2, and 3, and 4. And then we came to talk about solids that are amorphous. They're not arranged in a regular pattern. That's the only difference. There's no regular pattern. And these 2 lines, or the first 3 lines, kind of summarize everything you need to know. Thank you guys for reviewing these 3 sections with me. Study them very well. Have a nice day. Bye-bye.